Okay, let's go. Hi, I am back to do a re-recording of part 17 because the previous video yesterday was 720p. So how it happened was I bought a new webcam, because I was experimenting with different setup for doing our Code With Me streams. And I bought a new webcam because I thought I might have needed two of them. And the other webcam I used, the other webcam for streaming the first recording of part 17. And it turns out the maximum video quality for their webcam was 720p. So my streaming software automatically downscaled the video. And when I switched back to my old webcam, it was also at 720p. So yesterday I didn't set the output resolution back to 1080p, and I just couldn't stand the video quality. So here I am. It's like a special kind of hell, right? They say, the Eastern cultures, they say that when you're in hell, you're just stuck doing the same thing over and over and over again, or reliving the same thing over and over and over again. And I feel like this is what's happening for me for the past, okay, it's not that bad, but it's just 3 recordings, right, of the same thing. So I should be super good at this now, which means that I should be able to get it done within less than an hour. So let's get started on this one more time. Okay, so just to summarize what we are doing in part 17 again. So the blog, for those of you who are aware or not, we've released an article. So the release schedule for part 15 onwards has always been, we release an article first, it's going to be free until we release the video. And in the last video I said that part 17 will be dealing with adding extra stats. So we only have 6 stats now for the player, right? So then part 17 was going to deal with adding the rest of the 7 stats, because total there are 13 stats in Vampire Survivors. So originally the plan was gonna be that. Then when we were doing the part 16 video, I sought out to fix a bug that was pointed out by one of our forum members in the post here. So he very kindly took a screenshot of the issue, and this perfectly captures the issues that we have with our current pickup system, which is that if you go too close to a object and then you walk at a certain angle that is sharp, very sharp, to where it's supposed to move towards you from, the pickup is just gonna miss you, straight up miss you, because the pickup doesn't home in on you. It just tries to move to where you were initially at when you try to pick it up. So it misses here the play character, it misses the play character entirely. And notice also that even though the effect is, even though the pickup is missed, you see the player still gains experience. So basically this pickup is going to give experience to the player and then fly to the edge of the map forever, lost in space. Okay, so this is something that we don't want, right? Because if you have an object that's just flying forever towards a certain direction, it's memory leak. Memory leak is when you lose memory because you have an object or a bunch of objects that cannot be accounted for. They're just there, but they don't really do anything, right? Which is what the gem is doing. It's just doomed to fly diagonally downwards forever. So in this part of the series, this is what we're gonna fix. Initially, I was going to just add this part into part 16, but that didn't really work out because it turned out to be a more complex problem than I thought. So initially, when this topic was posted, this was back in December, I tried to fix it. So for me to run through with you the fixes that we need, I have to first talk about the problems with how the current pickup collection works. And the whole thing actually starts with the player collector script, which is right here. And what's going on here is that in the player collector script, let me just show you my version because the text is bigger. So in my version of the player, let's go through what the player collector script does. Okay, this was done back in, I think, part 2 or part 3 or something very early on. And it was done pretty simply, and there are a couple of optimizations that we can make to the player collector script. So before we talk about the optimizations, let's talk about the main problem with the player collector script. Okay, so firstly, it has a on trigger enter 2D, and this is what powers the entire script essentially. So the player collector is actually attached to the player himself. And let me just check whether I'm in the right screen, yeah? Okay, so the player collector is attached to the player character himself. And what's happening here is that there's circle collider, and this circle collider is paired together with the player collector script. And this is parented under the main player object. So notice that the player has two colliders. Okay, one which is the actual player's collider, and the other one is the collector radius. And the collector radius changes size when the game starts. So if I were to run this game, and if we were to check out the collector, you will see the collector's radius is larger now. And this is because the collector's radius is drawn from the player stats, which is right here. So this player has a magnet stat of 1.8, and this is why the radius is so large. So when you unplay it, the collector radius is just going to be set to a default of 0.5, but it's going to be updated every frame by the player collector right here. Alright. So what this circle collider does is it's just going to always be around the player, and then whenever it touches something that is a collectible, I'll explain what the collectible is. So if you forget, we've covered this in part 6, but I will just do a quick refresher because we're going to change how the collectible works later as well. So it checks whether the object is a collectible, and if it is a collectible, what it does is that it calculates the direction in which it's supposed to move. So basically it grabs the position of itself, which is the player, and the position of the object that is to be picked up. And it basically takes its position minus the object's position, which gives you a vector that points towards the player. And then I'll explain the math over here later, alright, in more detail, because we're gonna implement this somewhere else as well. So it basically gets you a vector that points to the player, and then it applies that vector as a force. So the object essentially flies towards the player. Nothing wrong with the math over here, it's perfectly good vector math. It's just that it only works for one frame, and therein lies the problem, because our player can move in any direction, right? So if the gem only moves in the first frame that the circle collider touches the gem, if it moves towards where the player is and the player is moving, when it reaches where the player should be, the player might have moved somewhere else. And this is why we get, again, problems like this. So to fix this, what we have to do is we have to get the gem or whatever pickup we are trying to acquire to follow the player. So it has to home in on the player. It can't just apply a force for one single frame and then just stop trying to course correct itself. Which means that we have to be updating where the gem is traveling towards at every frame. So this presents a couple of problems, because if we want to update the travel direction of every object that we pick up, let's say if you run through, you kill a bunch of enemies with a lightning ring or something along those lines, and then you got a bunch of gems. Okay, this is something that's not uncommon in Vampire Survivors, right? You got a bunch of gems on the floor, you move through a bunch of gems, and then they all get collected to you. So then the player collector, because right now it's managing the pulling, right? So if you have multiple gems that you are supposed to pull towards yourself, and you are supposed to update the direction of their travel at every frame, this means that you will have to keep track of all the gems that you have collected but have not reached you. And you have to update their positionings every frame. So it actually makes the player collector script become very complex. You can see my attempts at implementing this in the topic that is linked right here. So you will see I've put out a bunch of codes that ultimately didn't really work that well. Okay, it just didn't work at all, right? And that's because when I was writing this post, I wasn't in a position where I could test it. So I was just writing these codes on theory. You can see my thought process and what I implemented, how I implemented them, and why I implemented them if you check out the topic link in the in this post here. Even if you are not a Patreon and this post has been locked, you can still just click on this link and you will see the topic. The idea is that for us to have the player collector manage the homing behavior of the pickup, for every pickup is gonna be a lot of work on the player collector, and it's gonna make everything really complex. So when I set out to implement this, what I wanted to do was to let every pickup handle its own homing. So when the player collector touches the pickup is gonna just figure for itself. How am I gonna get to the player collector? So the logic for applying the forces and everything, we're just gonna move all of this stuff over to the pickup class. And this is actually a pretty good idea. Self-praise, right? Complimenting my own ideas, all right? So this pickup, sorry, let me just silence my phone. Okay, so this pickup class, right? Right now, it doesn't do a lot of things. It has a collect function that basically serves as a, let me just open up the scripts for the two other pickups. It serves as a parent class, and it has a collect function that basically, when you collect the pickup, it will mark the pickup as having been collected. This is so that you cannot pick up a pickup multiple times. It's possible if, let's say, you have multiple players, or let's say you're moving very fast, and then you can leave and enter the collider radius. It's going to register the pickup multiple times. So by flipping this to true, you only allow the player to collect this item once. Okay, this is relevant when you look at a health potion and you look at the experience gem. The collect function is the one that applies the effects of the pickup to the player. So it's very important that pickup only runs once. Collect only runs once, otherwise the effects can potentially be applied multiple times for one single experience gem or for one single health potion. So the other thing that the pickup script does is that when it touches the player, it will just destroy itself. Okay, so over here there are two problems. One is that when you call the collect function, automatically the effect of the pickup is applied to the player. You don't have to wait for the thing to fly over the player. And secondly, when it reaches the player, it destroys itself, which, well, it's not a problem, but the pickup script is very bare, and it really doesn't warrant having a class all to itself, alright? Just because there isn't a lot of code. At least in my opinion, I think there are different ways to code. I just like to make sure that my classes serve more of a purpose, alright? So what I'm going to do over here is I'm just going to move the behavior on the player collector over to the pickup script. So how this works is, let me just go through the code from the post. Okay, so what's happening here is that the main thing that's happening here is basically that I've added an update function onto the pickup class, and in the pickup class there is code that pushes the gem or whatever the pickup is towards the player character. So before we get to the update function, let's talk about the collect function over here first. Okay, so the collect function is gonna function the same as in the previous pickup class. When the collector's radius touches anything that is a pickup, the collect function is gonna be called. But this time the collect function is not just going to flip a boolean, as you see here. It's not just gonna flip a boolean, it's gonna populate a couple of variables. Essentially, it's still flipping the boolean, right? But right now we don't use a boolean anymore. So what we have here is the most important variable here is the target. And well, the speed is pretty important as well, but the target is the most important. So when you call collect, whatever target you pass on to collect is gonna be stored inside the class. So if you see in the class, there are three variables here. Target and speed are private. And target is basically the player that you are flying towards. So the reason why I implemented target like that was because, you know, this makes it so that it's possible to accommodate multiple players in the game. So in the future, if we want to implement multiplayer features, it's going to be easier. There are going to be multiple player stats in the future. And by doing so, you know, now because we are able to assign a specific player that the item is going to fly towards, It's just going to make multiplayer implementation easier in the future. Okay, so we assign a target to the class. We also assign a speed. Again, speed is protected. So in call collect, you're telling this pickup who to fly towards, how fast to fly towards, and then finally you have lifespan. What this lifespan is even though we have a homing code and I think it works perfectly fine, there may be a case where for some, say maybe you have wings or you have some item or some boost that makes you walk super fast. It is possible for the pickup to not be fast enough to reach you, and then you can outrun the pickup forever. We don't want a case like that. So what I'm doing here is I'm specifying a default lifespan of 0.5 to all our pickups, and you can override this if you want to inside the function itself. So what's going to be happening in collect is when we specify that there is a target and a speed so that the pickup knows to move towards the target and what speed, we also specify a lifespan. So if the item or the pickup, if it chases the player for a certain amount of time and it fails to reach the player, it's just going to destroy itself and then apply its effects to the player. So this prevents issues where, say, the item glitches out or just flies somewhere else. It will still anyway apply its effects to the player. This is just a failsafe to avoid any extreme cases when when our game is running. So this lifespan here limits how long the pickup can exist after it's been collected by the player and is trying to fly towards the player. So finally, we have this destroy function here, which destroys the pickup, and this basically just applies the lifespan. So if you understand, if you know how the destroy function works, the second argument in destroy is always going to apply a timer. So for example, if I put here destroy game object 0.5, then this is going to take 0.5 seconds and it's going to destroy the game object after 0.5. So what is this math max over here? What this is this picks the larger of the two numbers. So if the lifespan is a value that is below 0, what's going to happen here is it's just going to pick 0.01. So what this ensures for us is that minimally the pickup after being collected, it will exist for at least 1 frame, because 0.01 is around a little bit shorter than the time of 1 frame. So unless you run at extremely high frame rates, let's say 150 or 200, this is just going to take 1 frame and it's going to destroy the object after the next frame, after this frame. So what collect does essentially is that it populates the target variable inside the class. And if you look at the update function, if there is a target, we will move the pickup towards the player. So over here, we have a very similar mathematical formula here. And let me just explain the formula here, because target is essentially the player and then this is ourselves, right? Okay, so I'm just going to pull up Paint and just do some drawings and show you how all this stuff works. So we have an article about vector mathematics in our blog, and the reason I wrote that was so that, well, in our tutorials there's a lot of vector math involved, and I don't want to keep repeating the same points over and over again, even though I'm doing it now. So that's why I wrote the article. So when we release part 17's video, we will put the link somewhere in one of the corners, and also in the description below, so you can check out the article if you want to learn more about vector math. It's very interesting and it's not as hard as you think it is. Anyway, so we have, let's say, the player, and say its player is here, and then we have the pickup. So the pickup, let's call it X. All right, so what we want is for a vector that points from the pickup to the player like this. All right, so this is the vector that we want. To get this vector, we will have to grab, let's check this, we have to grab the position of the player minus the position of the pickup. So that will be P minus X. So whatever that you minus first, sorry, what am I saying? Whatever that is in front will always be where the vector is pointing towards. All right, so because we want it to point towards the player has to be the first thing, and then we have to minus this away from the position of the object, the pickup. So this will give you a vector that points from X to P. It's just the way vector math works, right? Okay, so once we get this vector, there are two things we can do with this vector. One is we can convert it to a unit vector, and then we can use it to push the object towards the player, because the vector is an arrow, right? So if you add it to the position of the object, then essentially you're moving the gem towards the player. Second thing we can do with this is we can measure the distance of this particular vector as well. So this vector, if you look at all vectors, they actually 2D vectors, they actually form a right angled triangle. So you can apply all kinds of trigonometry to them. But that is not the topic of, and not the point of why I'm drawing this. Okay, so what I want to talk about is, if you remember Pythagoras theorem, if you have the x and you have the y, you can calculate the length of the vector. So the length of the vector will be equivalent to the distance between the two objects. So over here, what I'm doing in the code here is I am grabbing this, which is a vector that points from the object to the player, and then I'm also using this vector as a way to measure the distance between the two objects, essentially killing two birds with one stone. And you will see there's something weird here, and the something weird is that I'm using the square magnitude of the vector and comparing it to speed times speed, instead of using magnitude, which is the actual length of the vector. So square magnitude is used because square magnitude is cheaper to compute. So every vector has a length, right? The length is calculated essentially from x square plus y square, and then you square root this. So this gives you the distance or the magnitude of the vector, right? So because square roots are expensive, instead of using the magnitude, what I'm going to use is I'm going to use the magnitude square. And when I use the magnitude square, what's going to happen is that I can just grab x square plus y square. So this is just a small optimization that I'm doing when we are when we are looking for the distance between the gem or whatever pickup it is and the player. So it's easier to multiply two numbers together than it is to square root a number, which is why I use square magnitude. Alright, so this is just small optimization. Time dot delta time is just a way for us to scale the movement. So time dot delta time, if we multiply it by speed, this will give us the movement in that particular frame, right? And why time dot delta time is necessary? Why don't we just take speed times speed and then specify the speed that is whatever the frame rate is, right? It's because time dot delta time will account for when there is lag. When there is lag, time dot delta time will increase, and this will cause the measurements and everything to change as well. So time dot delta time is a very important part of our formula here. So essentially what we are doing is we're checking if the distance between the gem and the player is greater than the amount of distance that the gem will be traveling for this frame. If it is greater than that, that means that the gem has not reached the player. And then we will push the gem towards the player by, now we're using the distance vector, but for a different purpose. We are normalizing it. And the reason that we are normalizing it is because normalizing a vector, essentially, let's say this vector we have, right? When we normalize a vector, what we are doing is we are getting the vector but with a length of 1. So the benefit of having a vector with a length of 1 is that it becomes something called a unit vector. And a unit vector is basically, because it has a length of 1, if you multiply by any number, it's going to become whatever the length you want it to be. So for example, if I want a vector that points in a certain direction with a length of 5, I will just grab the unit vector, multiply by 5, and I'll get the same vector pointing in the same direction but with a length of 5. Right, so this is an easy way. When we normalize the vector, it's an easy way for us to control how long the vector is, and by extension control the speed. So we normalize the vector, then we can multiply by speed and time dot delta time, okay, which gives us the amount of distance and the direction, of course, that the gem should travel for this particular frame. And because this distance vector is calculated every frame, the direction that the gem travels every frame is going to update itself, which essentially makes the gem home in on the player. And this is how the whole thing works. Alright, it's a bit of math. It can take a little time to understand, but it's going to be very beneficial for if you're going to be working on games, you will have to understand vector math. No way around it, right? Otherwise, it's going to be very hard for you to code different kinds of movements if you don't understand vectors. Alright, so if the distance between the gem and the player, or whatever the pickup is and the player is is less than the amount of distance that you will travel for this frame, that means that you effectively have reached the player, and then you just destroy the game object when the pickup reaches the player. So the pickup script has two changes. One is collect, which main thing it does is populates the target variable, and when it's populated, it will cause update to push the item towards the player. So the next thing we are doing here is we're just removing the onTrigger enter 2D function, so that because we don't need this anymore, we'll have a separate function later on that handles when the gem should be destroyed after reaching the player. Oh no, what am I saying? Okay, we are removing this because we are already handling the removal of the gem when the gem reaches the player. So notice one thing that we are doing with this pickup script also is that it removes the gems or whatever pickup we are dealing with. We are removing the reliance of the pickups on Unity's physics system, because now we are doing the calculations ourselves, and so this makes the entire thing run faster as well, which is always a good thing. So the last thing that we are doing, okay, we remove has been collected because its duty is now performed by target. Target is also a flag, right? So if it's empty, that means that the pickup is not activated, and then if it's populated, then of course the pickup should fly towards the player. So the other thing that we are doing here also is we are removing this iCollectible interface. And I guess your first question will be, what are interfaces? Interfaces, okay, let's look at what the iCollectible script does first. So what it is essentially is it's an interface that has a void collect, and what this does is that anything that implements this interface will have to have a collect function, okay, which pickup has, so it's fulfilling the interface's requirements, so as to speak. But interfaces are meant for us to use as a bridge whenever we have multiple hierarchies of different classes. So one example I can give for you is that notice that when we were coding our weapons, for some weapons it was particularly difficult to code the damage functionality for our weapons. Let me show you one example of this in our projectile script. You see, I'm getting better at talking about this, right? Because I've done this for 3 times now. So perhaps in the future when I record, I should just talk about, just do these recordings multiple times, right? Or maybe not, you know, it's a lot of work. So where's my projectile script? It's right here. So in the projectile script, you will see inside onTrigger enter 2D. What's going on here is we actually, when the projectile hits something, right, it's gonna check whether the other thing that it's hitting is either has an enemy stats component, or whether it has a breakable props component. So essentially what's happening here is that we're checking if the object is an enemy or whether the object is a prop. And if it's an enemy, we will damage it in a specific way. And if it's a prop, we will damage it, but in a different way. Even though both have a take damage function, we can't just check for both things at once. We have to check for them separately. That's because the enemy stats object and the breakable props object, or the classes, they both belong to different hierarchies. So if I were to draw this out, this will look something like this, alright? So we have enemy stats. And this enemy stats, because it represents enemies, in the future we may have different kinds of subclasses. Okay, so maybe we might have, just an example, alright? So we might have melee stats, and then we might have range stats in the future as well, or melee enemy or range enemy stats. Okay, just some random examples. Melee enemy stats, and then we may have range enemy stats. And then we may have more complex class structures depending on our requirements for the game. So depending on how many kinds of enemies we have and all that stuff, right? So there may be more subclasses depending on how many kinds of enemies you want to have. We will get to this when we develop the web enemy system and the spawning system further. Okay, so we also have another hierarchy of objects, right? So over here we have the breakable props. And again, breakable props in the future, depending on what kind of features we want to have, we may have different subclasses for these props as well. Alright. So they belong to different hierarchies, but sometimes because they both take damage, right? So we want to be able to manage both of these as the same kind of objects. So you can think of it as, let's say you run an ice cream store and then you sell, let's say, ice balls or some kind of ice desserts, and you sell ice creams as well, right? So even though they are different kinds of food, you handle them the same way. So in your code, this is what you want to do as well. So interfaces are one way that you can do that, and one way that we can fix this issue that we have is we can create an interface and we can call this interface, let's say, iDamageable. And then what this iDamageable interface is gonna have is it's gonna have a definition for a function called take damage, which will specify that anything that implements this interface has to implement the take damage function, for example. So if we were to have an interface like that that unifies both the enemy stats and the breakable props hierarchies, in our code, we can handle both of these as a single unit. So instead of doing enemy stats and then trying to find enemy stats, and then trying to find a breakable prop component and seeing which one is empty to see which component exists, right? We can just do this. We can just have iDamageable, same D, okay, and then we can just do other get component, iDamageable. So what iDamageable will do is that if there is an enemy stats, it will find the enemy stats. If there is a breakable prop, it will find the breakable prop because it treats both of them as the same kind of object. Alright, so essentially interfaces are there because you want to unify the hierarchies of two different classes of objects. So in our case over here, why is it that the interface doesn't serve a purpose? And it's because the interface is not used by multiple classes in different hierarchies. So the iCollectible in our code is only implemented by the pickup script. Okay, which means it doesn't do anything. It doesn't serve a purpose. Maybe in the future it will serve a purpose and we'll bring it back, but for now, because it doesn't serve a purpose, I'm gonna remove the iCollectible interface. Okay, and of course a bunch of other changes, so I'm just gonna copy this whole thing and just drop it into my code base. Okay, so all the changes that we discussed will affect the rest of our code, which means that once you make the changes to your pickup script, there will be errors that occur, there will be errors that appear, and you will have to start cleaning up all these errors. Okay, and that's what the rest of the tutorial is. That's what the rest of this part is meant to address. Okay, so let me delete the interface as well. Okay, we don't need the interface here for now. In the future, the breakable props and the enemy stats issue, we can consider creating an iDamageable for it. Okay, but we will do that when we get there. So today is just about the player collection system. So let's not cover too many things. So once you make the changes to the pickup script, we will have to also update a couple of things as well. And what are these other things? Okay, the other thing, the most immediate thing that we have to update is the PlayerCollector script. So what's happening with the PlayerCollector script, right, is that what's happening here? Okay, first, okay, the collectible is gone. So over here, instead of collectible, we can just use pickup. Alright, and then let's call this P as well. So it's shorter, it's just easier to refer to. Okay, the main thing that we have to address is that the collect function now takes 3 arguments. So that means that we will have to specify 3 things. Okay, who the pickup is flying towards, how fast it's flying towards, whatever it's flying towards, and finally, of course, what's the last argument here? Finally, it's the lifespan. Okay, so the lifespan is optional. So if you leave it at 0, it's just going to take the lifespan that is set in the default value over here, right? Which is totally fine. So what we want to do here is under the collect function, we have to give the player and as well as the pool speed. Okay, this will fix the issue in the player collector. And also because the movement has been moved to pickup, we can remove code right here. Okay, so our untrigger 2D is just going to be reduced to just specifying who the player we are flying towards and the pool speed. Okay, and that's really about it. That's about it for the main changes. The other change that I want to do, there are two more changes. First one is find object of type over here. Okay, this can be used when you have one single player. So we are just gonna lay a bit of groundwork, and then let's just change this to get component in parent. Because when you find object of type, what it's gonna do is it's always gonna find the same player stat. So let's say if you have multiple players and every player has a collector, it's always gonna find the player stats object of the first player, because find object of type will find the first object of this type. So if you have multiple player stats, you're not gonna be able to find all of them. Okay, every player collector, if you recall, is connected to a specific player because it's parented to a specific player, right? So we want, if we have multiple players, let's say we have multiple players, right? We want every collector to point to the correct player. So we cannot use find object of type. Instead, what we want to do is we want to just find the component in the parent object, and this will prepare our code for being so that it's multiplayer compatible in the future. Second change I want to make, okay, it's to rename the player collector circle collider. And what's happening here is that I'm just going to change this to detector. And one thing that you want to do whenever you try and rename a variable, very useful feature, is you can just right click and rename. And over here I'm just going to name it detector. It's just the smoothest outing name. Okay, you can keep it as the original name if you want to. I just like my names to be shorter and more descriptive. Okay, so the circle collider over here is just the size of the collector's radius. And one inefficiency that I find here is that the detector's radius is updated every frame. It's updated by the player stats. In the player stats, there is a stat called magnet, and then every frame it just retrieves the magnet and then it updates the radius. This is not efficient because the collider is linked to the physics system. So whenever you change the size of the collider, the physics system has to do some work to update the collisions and whatnot. So what I like to do instead is let's remove the update function and replace it with a function called set radius. And what set radius does, it takes a float r and it sets a detector radius be equals to r. Simple as that. Alright, and I'm also not gonna retrieve the detector's component in start. Instead, I'm gonna move this over here. If there is no detector, then for the first time we will assign detector as the circle collider in this particular game object. So why we move it over here is so that we only want to reset the radius, whenever the player stats is updated. So whenever there's a change in the magnet stats specifically, actually whenever there's a change in the player stats, we will want to just update the radius because the magnet stat could have changed. We don't want it to update every frame because again it's expensive to do that. So this set radius function is going to be called inside the player stats script later on. So whenever we try and change the stats of the player, we will call set radius. Okay, and this will cut down the number of times that this code will be running by a lot, which means more optimized code, alright, which is always a good thing. Why is it that I moved the get component from start over to set radius? And that is because later on because if the detector is populated only in start, we will not be able to call set radius whenever you have a wake function, and I want to be able to call set radius when there is a wake. So to do that, if I put this in start and then I call the set radius function and awake in a different script, the detector will not be present, and then this will cause a null reference exception. So to prevent that, I populate the detector the first time this function runs so that it's always accessible, always available. So then this function will never fail. It only fails if you don't have a circle collider, okay, which we're going to remedy also by adding a required component here and then doing a type of circle collider to okay. So what this required component, this is a directive, and what this directive does is that it ensures that whenever you have a player collector, it always comes with a circle collider. Okay, so the two can never get separated from each other. If you try and add a add a player collector to a game object, it's always gonna come with a circle collider. If you don't have one, it will add it for you. Okay, I can't show this to you now because I have other errors that we have to fix before the new scripts are applied. So whenever you get an error, your scripts don't apply. And then because scripts don't apply, you will not be able to see the new updates. Okay, so I'll show you this later if I remember. Okay, So the main change besides just the population of the collect function is the set radius. Okay, so the set radius, because now we have to specify when the radius is updated, which means that we have to head into player stats, and then we have to find all the parts in our player stats code where the radius is updated, and then we have to call set radius. Okay, simple, right? So because the player stats currently doesn't have a reference to the player collector, we have to add a player collector variable here. Let's call this collector. And then under awake, we will find both the inventory and the collector. Like this. And what we want the player collector to do is whenever the stats are updated, we also want to update the collector radius, which means over here, after the stats are updated, I'll do a collector set radius, and then the radius that is set will be actual stats dot. So this will be applied also to a couple of other places. This will be applied also to recalculate stats. And just a reminder of what recalculate stats is, it's whenever you receive a passive item or whenever you drop a passive item, the stats of the player will be recalculated. So if you wanna learn more, you can always refer back to the part 15 video to get a recap of how this works. Okay, so whenever I receive an item or I drop an item, I recalculate all the stats, and then whenever stats are recalculated, we have to update the radius as well. So over here, same thing, actual stats, and then so we have to find wherever stats are updated and just call collector set radius, and then this will do the job for us. So that's about all the changes. Let me check PlayerStats to see if I have captured all the changes. Okay, so while the article is still free, you can of course check it out before it becomes locked to be Patreon only. So after we fix the player stats, we still have a couple more things to do before we can apply these changes. Sorry, before we can see the effect of these changes on our project. So both our HealthPotion and ExperienceGem are subclasses of pickup, which means that if you recall, I was explaining just now, the HealthPotion extends pickup, and basically it just expands the collect function and it adds a functionality over here to restore the player's health. So whenever it's picked up, it will restore the player's health, and for the ExperienceGem, whenever it's picked up, it will grant experience to the player. Okay, it's all fine and dandy, except that again, the classes here are pretty empty. So whenever I find something that doesn't have a lot of code, I like to delete these. Okay, so we are gonna merge the functionality of both the ExperienceGem and the pickup, and the HealthPotion into the pickup class. So I'll delete HealthPotion here, I'll delete ExperienceGem here. And in the pickup class, I'm gonna add the bonuses here. And over here, this will be experience and health. So we want our pickups to, we want it to be possible for our pickups to grant either experience or health, or both. And the reason I moved it over to pickup was because HealthPotion and ExperienceGem don't really do much by themselves. This doesn't mean that this pickup class is not gonna, this doesn't mean that we're gonna use the pickup class for everything. So if you recall, in Vampire Survivors, there are a lot of different kinds of pickups. Okay, there are pickups for, there's one pickup that causes you to spew fire, there's one pickup that causes you to stop time, and there's another one that causes you to attract all the gems to you, right? So for the more complex pickups, we will still subclass the pickup class over here, because there's going to be a lot more code. And for the effects of the pickup, because right now it's pretty rudimentary, okay, we can handle everything in the pickup class. So I'm just moving this over to pickup, and what we're going to do is, remember that we want to make sure our pickups only apply the effects after they reach the player. So how do we detect that the pickup is reaching the player? We detect that by whenever the pickup is destroyed, we can assume that the pickup has reached the player. Okay, there are two conditions wherein a pickup will be destroyed. The first condition is that it has touched the player. Second condition is that it has tried to fly towards the player for long enough and it's just ran out of lifespan, right? It just destroys itself after that, okay? So to that end, we are just going to add an onDestroy function to our pickup class, which is right here. So this onDestroy function, what it does is that it detects whenever the pickup is destroyed, and then it just applies its effects. So we've made it virtual because in the future, if we want to subclass the pickup class for, let's say, the more elaborate pickups, we can do so. And then it's protected so that it's only accessible by child classes of the pickup class. So here we are checking if the experience or the health is not equal to 0, and only if it's not equal to 0, we will call either restore health or increase experience. Okay, so it's possible also for pickup to reduce your experience or reduce your health, okay, if you supply negative values. It's just that we don't want the effects to apply when the value is 0 itself. And the reason for that is because it's possible for us to add additional effects to increase experience and restore health later on. Let's say if you want to create an item that boosts the amount of health that you get from healing. Let's say for every time you get healed, you get 1 extra hit point. Okay, if we do that, and then because whenever we pick up a pickup, because the pickup both grants experience and restores health, if the health is set to 0, it's possible for additional effects to apply in the future. Right now there are no additional effects, so it's fine, but in the future if we want to put additional effects onto, say, restore health, if we have ExperienceGem, because it heals 0 health, it will still trigger any healing effects. So we don't want any healing effects to apply when the item is not supposed to heal, which is why we exclude calling restore health or increase experience when the values are 0. Why is target here? Target is here because as whatever pickup we have is flying towards us, it's possible for the player to die. So it's possible you pick up a health potion, before it reaches you, you die. Okay, in such cases, if you die, then target becomes null. If target becomes null, then target dot increase experience or target dot restore health is gonna become null increase experience or null restore health. This will give you a missing reference exception or a null reference exception, which was just an ugly error to have, right? So if we check that if the target is dead and we stop running the rest of the function, this will prevent a potential missing reference exception or null reference exception. Again, this is something that we have explored a lot. We have a video for that, and we will drop the link to that video when we turn this into a part 17 video. Right now it's just a stream. Okay, so now that we have merged the ExperienceGem and the HealthPotion into the pickup, let's see if we have any other errors. Okay, one last thing we have to merge into the pickup script, and that is the bobbing animation. All right, so the idea behind putting the bobbing animation as a separate script is so that you can apply this animation script to other objects. So you can, anything that you want to bob. So let's say if you want a prop to be bobbing around but not actually collectible, you can add that. The problem is that the bobbing animation script was coded to work with pickup. So even if it's separate class, it cannot work without a pickup component. So it becomes a little bit redundant, which is why we want to merge this into the pickup class. So another reason that this merging is good for our program is because generally if you have different behaviors spread out over different scripts, right, it becomes harder for Unity to retrieve the values because they can be stored in different parts of your memory. And then the further away they are, the harder it is to retrieve all their independent values. Okay, so when you have everything in the same class, then the variables inside the class will always be stored in the same location, and it's gonna be easier for Unity to access them, which again means that your code will run faster. So very fortunately, the bobbing animation actually merges quite well into the pickup script. I'm not gonna explain the math behind the bobbing animation over here because everything is already explained in part 6 of our series, so you can check that out if you want to learn more, if you want to recap what this formula does. I am just going to transfer all of these variables into pickup and make a few adjustments to how they are organized. Alright, so the three main variables we have here are frequency, magnitude, and direction. And magnitude can be combined in direction because vector can represent magnitude as well. So I'm going to move these three variables into pickup, but it's going to be a little bit different. And how it's different is that I'm going to we are going to put this as a struct. Okay, so only the frequency and direction needs to be transferred over. Okay, so just to save the data of the bobbing animation. Okay, you have frequency, you have direction. And this is saved under a struct. So a struct is essentially just a class, but they are passed by value. And so this struct is now only going to exist inside the pickup script. A struct, you can think of them as classes, right? They're just classes. Okay. Later on, I'll show you how this appears inside the inspector, and it'll make sense to you. So whenever we declare a struct, we are able to create variables of that type that the struct is. Okay, so this variable is going to contain two values, frequency and direction. Okay, and then over here we are specifying a default value for the variable, and because this variable is a struct, it has two default values because there are two properties inside the struct here. So I'm declaring the default value for the frequency to be 0.2, and the default direction here will be 0 and 0.3. So with the bobbing animation struct set up and the variable set up, I can now add a else condition over here, and over here I can just transfer the formula over to our pickup script. And of course, when we transfer this, we are gonna have to also change the variable names a little bit because we changed the variable names in bobbing animation over here, right? Right now it's stored inside a struct, so we have to put bobbing animation dot direction and bobbing animation dot frequency. Magnitude we didn't transfer over, so we'll just delete this. And finally, we have this initial position here. What is initial position? This records where the object is initially, so that it's always gonna bob relative to where it's supposed to be, right? So the initial position is just where the pickup is supposed to be. So this will be a vector 2, and this will be a private vector 2 over here. And how the pickup is gonna work is that whenever it's spawned, it's gonna record where it's supposed to be. It's gonna stay there, but it's gonna move around. So the initial position is gonna be part of the formula for the pickup. So we are also gonna add a protected virtual again so that we can override it in child classes or its start. And inside the start function here, we are going to just set the initial position to be equals to the position of the pickup. So I would say the bobbing animation script actually fits very nicely into the pickup script because the pickup script does two things, right? If it's not collected, it will just bob. If it's collected, it will start moving towards the player. So the if and the else here is just perfect. And once we add all of this stuff, we will be able to update our prefabs so that they start working. So let me go to the console and I will clear. Okay, last thing we have to do is just delete the bobbing animation script, and we should be free of errors. So now everything is contained inside pickup. Okay, the HealthPotion, the ExperienceGem, and the bobbing animation, right? Which means that when we go to our prefabs, right here, we have to remove this is the old bobbing animation script, and then this is the old pickup script, the HealthPotion script, right? So we just replace that with new pickup script over here, and you'll see the pickup script here has a lifespan. Bobbing animation, because inside a struct, it becomes like that. And then there's frequency, and then there's direction, and you see the whole thing is quite neat, right? It's quite clean, easy to read. And then you have bonuses here. So the HealthPotion is going to restore 500 health, 0 experience, and then for the blue gem, let's save the prefab. For the blue gem, Again, we have to remove the old scripts over here, and then we just add a new pickup script. And then again, everything is set for us because we have set the default values inside the pickup class. So when we add a new component, it's just going to assign the default values for us. We just have to modify the experience to the old value that we have, and we can start testing out the items. Okay, one last change, right, before we test this out is you have to reduce the pull speed to 10. This is because previously the pull speed was if you recall, in the on trigger enter over here, what we have is we used add force. And add force, for those of you who are not familiar with physics, force is equals to mass times acceleration. Okay, so force is equals to mass times acceleration. So when you add a force, to find out what is the change in the speed, this will be F over M. Alright, so what I'm trying to say to you is if you add force, the force is always going to be, the speed that you get is always going to be smaller than the force you apply because everything has mass, and then you're always dividing the force by a certain mass. So because now we are just applying, if you go to pickup, now we are not caring about how we're not using physics to move the object, we're just setting the position directly. So this means that if your pull speed is 300, it's going to be moving at 300 units per second. Okay, it's not going to be applying 300 units of force per second. Okay, it's totally different. It's totally different scenario over here. Okay, so because of that, we reduce the amount of pull speed to 10 because right now it's just representing speed, not force. So you need a smaller value, otherwise the gem will just instantaneously reach it. Okay, so if we play this and let's just start collecting some items. I'm just gonna place a couple of health potions and blue gems, and you will see that it works a lot better. The gems will start following the player when you get close. Or maybe not. What's going on here? Let's have a look here. So our collector is not being updated. Problem. So the radius over here is not being updated. I've got to find out why. So let's head over to PlayerStats and see what's going on. So we have recalculate stats, actual stats, magnet. Let's check whether the magnet stat is updated. So player under player stats, magnet is 1.8, but collector stat radius is not working. So let's go back to PlayerCollector. I probably missed something here. If there's no detector, then get component. And then detector radius goes to R. Okay, just give me a short moment to. Sure, I missed something. Let's try this again. And let's look at the message over here. Null reference exception. So we have a null reference exception over here at line 229 of PlayerStats, and that is probably what's causing the stat to not update. Oh, okay, so sorry, small mistake over here. Under player stats, right, this is supposed to be get component in children. Because the player collector is a child of the player stats, right? So the player stats is right here. But then the collector is a child. Okay, so this is reflected in the article. It's just something I messed up. So if we look at the player stats, okay, you see right here when we initialize the collector as get component in children. Okay, we cannot use get component because then that wouldn't find the player collector, which is under the player stats object. So now with the code fixed, the collector radius should update appropriately, like that, which is fantastic. And then when we collect our items, that should fly towards us. So there's gonna be tracking as well, which is pretty cool. So if you move really fast, it will track you. So it's never gonna fly by you anymore. All right. So in our YouTube community post, you will see one graphic that where you have the gem curving very nicely to reach the player. Okay, I'm gonna leave you to go and play around with this and test this yourself. Okay. I think it's pretty cool that the homing feature is working. So before I wrap up this stream, there are two more things I want to cover. Okay, one of it is bug fix, and the other one is just a quality of life improvement. Okay, so the first thing is the bug fix, which is under 4B of the article. Let me just show you how the bug happens. Okay, so let me just take some damage, and we have a health potion on the map, right? So just take some damage over here. I hope I don't kill the bat. So I'm going to take some damage on the player. Scale this up. And now if I pick up the health potion, right, the health doesn't update. And then only after I get damage does the health update. And this is because just small oversight on the PlayerStats script. Where is this oversight? When we have increased health. Sorry, restore health over here. We also have to update health bar. Otherwise, the health bar will not update. And same thing under recover. So if you have Palma Roller and the character is healing, the healing doesn't actually reflect on the health bar until you take damage. So right now only take damage. Or is take damage. Only take damage updates the health bar, which is why you only see whenever you heal the character, you have to take damage and the health bar updates. Right. So by adding the update health bar into the restore health and the recover function, this fixes the issue that we have. So if we test this out again and we see what's happening here, now if I pick up the health potion, the health bar immediately updates. No longer does it take a while. No longer does it take me taking more damage for the health to reflect. Let me just show this to you again. So I'm taking damage, and then restore health. Health restores the moment the health potion reaches the player. Okay, so this is one bug fixed. The other thing that I want to address isn't really a bug fix, but it's possible in Vampire Survivors, happens a lot, right? When you get big AoE weapons, that multiple enemies will die at the same time and you get a bunch of gems on the floor. When that happens, because we have a bobbing animation, the items are all bob to the same rhythm. Okay, let me just show this to you in game as well. Just drop a bunch of items on the floor and you will see they all have the same rhythm, which is it's not a big problem. It just looks very robotic. So one way we can fix this is we can head over to the pickup script and we can just randomize the bobbing animation a little bit. Okay, so we'll introduce a float initial offset. And what this does is this is just going to be a random value between the frequency and so between 0 and the frequency. And what this is essentially what this is this is just a random value that we add to the time in the formula over here. And what this does is because the sine curve, right, the sine curve looks like this, right? So this is how a sine curve looks like. And the sine curve basically causes the object to move up and down, up and down, up and down. Okay, so what we want to do is we don't want the object to always start at 0. We want some of the objects start curving here, some to start curving just anywhere random between the peak of the curve and the bottom. Okay, so then by adding this random offset over here, this will ensure that our curve doesn't always start in the same place. And this will give us some amount of randomness to the to the animations of the objects, which makes everything more organic. I understand that in Vampire Survivors itself, you don't have animations for objects, so this is just something that it's an improvement of the Vampire Survivors game, right? Okay, so you can also choose to just disable the animation, in which case you won't have to worry about randomizing the bobbing animation for the items. Okay, but since it's there, let's make it good, alright? Let's make it better than what we have, than the default one. So with that is all. So the order of this stream is a little different from the articles, because I wanted to just do it in the most organic way possible. But the article basically documents everything that I've just covered in more detail. So you can always check that out until it becomes Patreon exclusive. So that's about it. In the next part, what I'll do is what I initially set out to do, which is to generate or rather create the rest of the stats. So we have 7 more stats, and that will happen tomorrow in the code with me stream, where I won't be conversing. What I'll be doing tomorrow is I'll just be coding, and I'll just play some music, and then have some there'll be some typing sounds as well. So tune in, and thanks for your support. Thanks for all the kind comments. It's really great. I always appreciate comments because it helps to remind us of why we are doing all of this stuff, right? It's for you guys. So before I go, let's check out the chat to see if there are any questions. Okay, so thanks for tuning in for those of you who did. That's all for today. So I have some work, some other work I need to finish before I go to bed, and I also have to prepare for the stream tomorrow. So once again, thanks for tuning in, thanks for your support. I'll see you guys tomorrow.